Hello there, welcome back to 6-8 Part 2, and today we are going to finish off this lesson on basic anti-differentiation rules. Just a reminder, what we're trying to do here, our learning intention is to be able to anti-differentiate algebraic or symbolically represented functions, kind of like you see here on your screen. Again, here's a reminder of the basic or foundational integration rules that you should know. You should know the integral of sine and cosine, your trig functions, the integral of e to the u, always think Spider-Man. And then we have the power rule, which is kind of your bread and butter, and as well as u to the power of -1. So a lot of people think you're going to apply power rule to something written like this. However, I know if I raise the power of that -1, that's 0, and we cannot divide by 0. Cannot use the power rule for there. So this is actually the integral of 1 over u is the natural log of the absolute value of u. So what we're going to do today is we are going to look at some important properties, and we've kind of been using these. We've kind of done this with definite integration so far, but we're going to see how this applies to indefinite integrals. And again, just a clarification on definite versus indefinite. Definite has limits of integration, a to b. Notice none of these have an a to a b. It's just asking you to integrate. So these are called indefinite, I-N, indefinite, and I'll write that right here. So indefinite and again definite are the same type, like the rules apply exactly the same. It's just you know, I don't have to plug in numbers and evaluate, which we'll do in the next video. Darn, I know you're looking forward to it. All right, so let's jump into this. Important properties of integration, hashtag remix. The properties are as follows. Number 1, the integral of a of f prime dx is equal to, well, the first thing that you should know with a constant is that you can go ahead and pull it out. This is a times the integral of f prime of x dx, which just ends up giving you a times f of x plus the constant, okay? So that's very simple and straightforward. Number 2, if you're just integrating a constant, if you're integrating a constant here, and actually here's what I'm going to do. I don't like this. I'm going to make this a k. If you're watching this in the future, it's probably already a k because I'm going to change it. The integral of kx dx is equal to k times x plus some power of c. So if you're integrating a constant, an example this would be, what's the integral of 2 dx? Well, it's just going to be 2x plus some constant. And notice our constant, that plus c, that for indefinite integrals, whenever I don't have limits, we always add that constant because I could have, you know, some number there when I differentiate to get this. When I utilize that antiderivative, I have to account for that constant. I don't like the double c here, that's why I changed it to a k. Number 3, the integral of f prime of x plus g prime of x dx is equal to, well, this just says I can go ahead and I can break this apart. This is the integral of f prime of x dx plus the integral of g prime of x dx, and this is going to give us f of x plus g of x plus some constant. Okay, now each of these would have their own constant, but again, you add a constant and a constant together and it's still a constant. So f of x plus g of x plus c is what you get there. And then b, the integral of nothing. It doesn't look like there's anything in the integral. Well, there is. There's an invisible 1. So this is just going to be x plus c. Okay, and it kind of follows from 2b. I guess I should have gone this way. The numbering is a little weird. So let's go ahead. Let's try some examples. Here is example number 7. Ooh, look at all those terms. I'm taking the integral of all of those dx. And I want you to notice too the structure of my integrand. Notice how there are brackets and parentheses around this. You want to do this. If you have a function that's multiple terms, put parentheses around it and then include your dx, okay? So it's just saying I'm taking the integral of all of this. So what can I do? Well, that property that we just looked at, number 3, I can take the integral of each piece of this. And I'll write this for this first term, right? But this is the integral of x cubed dx minus the integral of 2x squared dx plus the integral of 4 over x dx minus the integral of 1 dx, okay? And what I'm going to do is I'm also going to do some manipulation here of the properties that we just saw, and this is beneficial going forward for simplifying some algebraic things. So notice I have a constant, that 2 in the front. I'm going to take out that 2, and I have the integral of x squared dx. And the same with this 4. I can take out that 4, and I have the integral of 1 over x, which, again, I'm going to make that x to the power of negative 1 dx. I'm going to bring that up, minus the integral of just dx. You can keep the 1 there. I'm just going to kind of get rid of it just so you kind of see what we had in the properties up above. So now let's go ahead and integrate this. So I have the integral of x cubed dx. Okay, no biggie. That's x to the 4th divided by 4. Okay, minus 2 times the integral of x squared. Well, that's going to become x cubed. And I'm going to divide by 3. All right, no challenge there. Plus 4 times, this is x to the negative 1 power. Anything to the negative 1 power, that's the natural log of the absolute value of x. Okay, and then last but not least, we have minus the integral of dx, which is just going to be x plus some constant. I'm going to add a constant there. Okay, and there is our answer. I just took the integral of each piece. And some of you are like, do I have to write all of these integrals in between? If I just know that, can I just go straight to here? Sure, you can. But I think it's important to see that progression. All right, B. The integral of 2 cosine of x minus 3 over x plus 5 square root of x. So I'm going to do some preparation here. I'm going to make this 2 times the integral of cosine of x minus 3 times the integral of x to the negative 1st dx plus 5 times the integral of x to the power of negative 1/2 dx. Okay, and I just went ahead and I just kind of manipulated those so they're ready for integration. And now I can go ahead and integrate each piece. So the integral of 2 cosine of x. Well, what's the antiderivative of cosine of x? How do you get cosine of x from taking a derivative? Well, that's going to be sine of x. So 2 sine of x minus 3. This is the natural log absolute value. Yes, you have to have the absolute value in there of x plus 5 times x to the power of 1/2, and I'm going to divide by 1/2, so that means multiply by 2 over 1, okay, plus a constant added here. And if I wanted to go ahead and just kind of simplify that last piece, so I have 2 sine of x minus 3 natural log absolute value of x plus 10 x to the power of 1/2 plus a constant. Okay, so there you go. Nothing too shocking. We just have lots of terms in there. So we're going to go ahead. We're going to now look at some tricky integrals, because all of these so far, and this title is called Basic Integration, have been very, very straightforward. But let's look at some that are not straightforward. Yes, this is where the fun begins. So when integrating, what we often need to do is we will need to manipulate or simplify the integrand before attempting to integrate. Don't rush into integration. Be on the lookout to see if the problem can be simplified first, okay? So algebraic simplification skills do come in handy. Yes, they do. Number 3, one thing that we don't have equipped for integration is what we have in differentiation, which is a product rule and a quotient rule. So we don't have these. So when you're integrating, you're like, hey, they're multiplying. Hey, they're dividing. I'm going to use product and quotient rule. Well, no. Are you integrating? Okay, we don't have those. We don't have those tools in our tool belt. So, sorry. You can only use them for differentiation. Okay? So what we're going to have to do, we're going to have to simplify them first somehow. We'll see some of those. Number 4, know your derivative rules. This is very, very important. I have some flashcards that I will make sure I print out and provide to you. Remember that the antiderivative is the inverse of a derivative. So that's what's beautiful about calculus is you can go ahead and you can work a problem 2 ways. You can differentiate things to get certain items. You can integrate items to get certain items. And that's why on the multiple choice test portion of the test, you can work problems forwards and backwards to see, if your answer is correct. Okay, pretty cool. All right, example 8. Let's look at some of these. All right, I have the integral of 3x minus 1 times x plus 4. Hey, they're multiplying. I'm going to do product rule. Well, sorry, Charlie, you don't have the product rule here. And that, how cool if your name is Charlie and you're watching this. And you're like, hey, she's talking to me. I knew you were watching this, Charlie. I made this video just for you. So what I'm going to do, I'm going to go ahead and, how do I simplify this? Well, what I'm going to do is I'm going to FOIL this. I'm going to go ahead and I am going to distribute my terms. And I'm just going to make one polynomial in standard form rather than a polynomial in 2 binomials. So I have, we get 3x squared plus 12x, minus x plus 4, minus 4, and all of this is with respect to dx. So notice how I'm keeping my notation, and notice how everything is nice and neat. And now I'm going to go ahead and I'm going to combine my like terms. So this is 3x squared plus 11x minus 4, and all of this is with respect to x. So right there, that's the simplification process. That's it. I just put it into a form that I can work with. There's no shortcut there. So now I'm going to go ahead and integrate this, and what we get is x cubed, right? 3 divided by the new power, these cancel, x cubed, plus we have 11x squared divided by 2, minus 4 times x plus a constant, So I really don't need this. I guess you could leave it as, 3x cubed divided by 3, but there you go. There's your answer. All right, B. We have the integral of cosine squared of x times secant x dx. Wow, this looks really ugly, and I have shown you nothing that looks like this thus far. So let's see if we can break it down. And you guys know with secant, with any trig functions, we can represent them various ways to simplify. And there are even some integration methods and antiderivatives that I have not showed you just to keep it simple. But looking at this one, using your basic knowledge of reciprocal functions. So I have cosine squared x times secant. Well, secant, I'm just going to rewrite it. And if whenever you're working with trig, if you're ever stuck, if all else fails, just rewrite everything in terms of sine and cosine. And that generally makes our life so much easier. So here, the reciprocal of secant is cosine. That's 1 over cosine dx. And lo and behold, I have 2 cosines. Isn't that cosine times cosine? So this cosine cancels with one of these cosines. And now I just have the integral of cosine of x with respect to x, which we know is sine of x plus c. Okay, not too bad. Again, if you struggle, actually, don't box your answer. Don't do that, because then the reader, just don't do that on the AP test. It's advised not to box your answer. Okay, so again, if you need to draw like a little diagram to help you remember, this little diagram right here is awesome for derivatives, right? Boop, this is the derivative. And then the integral works backwards. Integral works backwards. C. The integral of 2x minus 3 to the power of 2 dx. Oh man, there's a power of 2. But what I want you to see is that I have a function inside of another function. 2x minus 3 inside of another function. So there is a quick way to do this. You're going to like this. Actually, well, you probably won't. I don't know if you like it. But it's a major simplification tool that I teach you in, I think, 2 lessons forward. But right now, what we're going to do is we're gonna take the old brute force approach to this integrand. And what I'm going to do is we're going to go ahead and just expand it. And then we'll go ahead and FOIL it. So we've already done this, right? Haven't we? So 2x times 2x gives me 4x squared. Looks like we have minus 6x minus 6x plus 9 dx. Okay, and I'm going to go ahead and now integrate this. So we have 4/3 x cubed. This is minus 12x. So that's going to be minus 12 divided by 2, x squared, plus 9x. I get a little scared every time I start doing some shortcuts. I feel like I'm going to make an error. I like to do everything kind of straight out. I think I'm okay. Let me know in the comments below if I goofed this example. Okay, and then there is our antiderivative. Pretty sweet. One thing to note too, when do I get rid of my integral sign? When do I get rid of the dx? You should be asking yourself these questions and checking this to make sure notation-wise, because this is a common error I see students. When do I drop my dx? When do I get rid of this integral sign? Some students like to go ahead and do some of the integration in the integrand. They start raising these powers before they drop this. And the answer is, as soon as you utilize the antiderivative rule, that integration process, as soon as I raise that power, that integral symbol should be gone, okay? And if you're only doing it one term at a time, like maybe, I don't know this one, you have to keep that integral with the dx on a specific term, okay? So anyway, that's just regards to notation. D. Ooh. The integral of x squared minus 4x minus 21 over x plus 3 dx. Now again, you do not have a quotient rule here. I'm not going to go ahead and do some magic rule here that I haven't shown you. What you have to do is you need to simplify. Now how do I simplify this? Well, with the beautiful F word of mathematics, which is factor. I'm going to go ahead and make this x minus 7, x plus 3 over x plus 3 dx. And what happens? Well, I have an x plus 3 cancel. And then now, oh my gosh, look at how nice and easy that integral is. This is just cake, guys. X squared 1 over 2 minus 7x plus c. See, calculus, a lot of it is just pompousness. Everyone's like, oh, I can do, don't box your answer. Don't do that. Don't do that. Oh, calculus is so hard. I could never learn calculus. Man, you must be smart. You can do calculus. No, it's easy. It's like being a magician. It's just a bunch of tricks. Just a bunch of tricks. All right, here's E. Here's E. The integral of the square root of x times x squared minus 3 dx. Okay, so again, we're going to simplify this. And again, with the radicals, really, I want this to be x to the power of 1/2. So I have x to the power 1/2 times x squared minus 3 dx. And what I'm going to do is I'm just going to distribute this in. Okay, so this becomes the integral of, I have x to the power of, this becomes 2 over 2. Maybe I should rewrite this. This is x to the power of 4 over 2. So when I go ahead and multiply this in, we get x to the power of 5 over 2, right? I'm gonna add those exponents. If this is just a little bit of algebraic reminder here, x to the power of 4/2. When we multiply these, we add these exponents, right? This is 1/2 plus 4 over 2, and that gives us the 5/2. Okay. Minus 3 times x to the power of 1/2 dx, and we'll go ahead and integrate now. So, okay, we get x to the power of 7 over 2. Remember, I just added 1, which is 2 over 2, plus 2 over 2, okay? Divided by 7/2, which is 2/7. Okay, minus 3x to the power of 3/2 divided by 3/2, which is 2/3. Okay, plus a constant, plus our c value. Don't forget your plus c. Don't forget your plus c. So this gives us 2/7 x to the power of 7 over 2, minus our 3's cancel, and we had 2x to the power of 3/2 plus c. Okay, and again, if you're ever wondering, hey, did I do this right? Did I integrate right? Well, work it backwards. What if I differentiate this? Use the power rule. 7/2 times 2/7, those are going to cancel. Drop the power by 1. You get 5/2. Yep, did it right. Here, I'm going to multiply by 3/2. The 2's cancel. I get a 3 in the front. Drop the power by 1. Hey, did I get that? Yes. Derivative of a constant. 0. Okay, so there you go. There's our antiderivative. Okay. F. The next 3 examples, these are the last 3 of the video, and the last one will be a practice problem for you. But they deal with monomial denominators. And I'm going to write this right here. Monomial denominators. Fancy mathematics way, fancy complicated way of saying you have one thing in the denominator. Do you guys see the one thing? When you have the one thing in the denominator, the monomial denominator, what you're going to do is you're going to split. Split. So I'm going to have x squared over x to the power of 1/2. That's square root of x, right? Plus 4x divided by x to the power of 1/2 minus 2 over x to the power of 1/2. And again, all of this is dx. So what I did here is I just divided every single term by the denominator. Now you can do this with, if you have a binomial, but you divide every single term by that binomial, and it's not as effective in simplification. Again, I don't have a quotient rule to go ahead and simplify this. So what I'm going to do is these are going to cancel and simplify with each other. So if I have x to the power of 2 over x to the power of 1/2, lots of ways to go ahead and simplify this, but hopefully you remember that this is x to the power of 3/2, right? You're just going to subtract the powers. Here we have 4x to the power of 1/2, those powers cancel, or you subtract them, right? X to the power of 1. 1 minus 1/2 is 1/2. And then here I have 2x to the power of negative 1/2. I just bring that up into the numerator, and now all of these are just simple power rule integration. Okay, so we have x to the power of 5/2 divided by 5/2 gives us a multiplier of 2/5 plus 4 x to the power of 3/2, so it means we multiply by 2/3. Okay, minus 2x to the power of, put this over here, 2x to the power of 1/2, and we're dividing by 1/2, which means we multiply by 2 over 1 plus our constant. Okay, and so I'll go ahead and I'll simplify this. So we get 2/5 x to the power of 5 over 2 plus 8/3 x to the power of 3/2 minus 4 x to the power of 1/2 plus a constant. There's your antiderivative. All right, last two. Here's a very, very basic one. Here's a very, very basic one. Monomial in the denominator. I'm going to go ahead and split. I have 3x to the power of 4 over x minus x squared over x plus 3 over x dx. Okay, and simplify. So this gives me the integral of 3x to the third minus x plus 3x to the power of -1 dx. Okay, and I'm going to use a combination of power rule, antiderivatives, and also my natural log for that last one, right? It's power of -1. So what we get here is we get 3/4 x to the power of 4 minus 1/2 x squared plus 3 natural log absolute value of x plus the good old constant. Okay, and there is your antiderivative. All right, last example here is h. Go ahead. I want you guys to try this. Pause the video, give this a go, and then you can check your answer. Okay, so hopefully you went ahead and simplified this first. This should have given you x squared over 4x squared plus 3x over 4x squared plus 7 over 4x squared. So notice all I'm doing is splitting it. I'm putting that in one term in each denominator. And then now I'm going to go ahead and simplify this. So this gives us, the x squareds cancel, and I just have 1/4 plus, what do we got here? 3/4. This x is going to cancel with that one. I'm going to have an x in the denominator, so that's going to be x to the power of -1 plus 7 over 4x to the power of -2. And all of this is with respect to dx. Okay, so now we'll integrate, and you should have gotten 1/4 x plus 3/4 natural log absolute value of x plus 7 over 4 x to the power of -3, and you're going to divide by -3. So I didn't have any room, so I'm going to put times a -1/3 there, plus a constant, okay? And this would have been the final answer. See if you got it. Okay, minus 7/12 x to the -3rd power. All right, that's going to do it for this video. That is basic anti-differentiation. We'll get more crazy and complicated with it going forward. But again, remember to simplify. If it looks crazy complicated, try to simplify it first. Like and subscribe. Chop chop. Go ahead, watch that video. I'll catch you in the next one. See ya.